So as Steve mentioned, I'm here to talk about security enhancements. So these are primarily focused on things I'd say for maybe the last 3 months, give or take, the last kind of major release, or insight into what we've got planned for the next, 4 months. There'll be a little bit of overlap kind of with pre-existing things, especially when I think it's relevant to highlight. But it's by no means a comprehensive talk about all of the security things that we do in terms of our code base, in terms of our development practices, in terms of our deployment practices. So please feel free to log those questions in the chat. Happy to loop in on those at the end of the session. And you've probably seen a slide that looks a lot like this one. If you've been here for more than past half hour, Adam gave a great intro. Thanks for the warm up of the crowd, Adam. And these are, like I said, the main things that we've been focused on recently that we think are generally applicable. And one of the fun things about being able to present here is that I'm talking about work that the entire engineering team has been involved in, and so we'll try and highlight some of the key people in each of these different areas as I go. Sorry for LabKey folks if you did participate and I don't call you out, but don't feel like I can name everyone on every single story. And I guess the other thing to kind of think of as a running theme here is that security and usability are kind of on this continuum and sometimes at odds with each other. So a lot of what we're trying to do when we prioritize changes, make enhancements, is to make sure it will be adopted smoothly by all the organizations that are currently using LabKey Server, or that are going to be coming on board in the future. Part of the frustrating thing about security decisions is kind of the asymmetry of the relationship between a potential attacker and the defender. The defender effectively needs to be successful 100% of the time to repel every attack, whereas an attacker only needs to be successful once in order to extract data, cause a denial of service, any of those types of interruptions. And so, we, as Adam and Steve have both mentioned, security is really, a paramount concern here, and that we are thinking about it throughout our entire process, but then also thinking, how do we, roll that out in a way that isn't disruptive to folks, but still provides the maximum, security and usability across the board that we can. So with that, let's get into some specifics. So password rules. We have, for a long time, since day one of LabKey Server, even before it was called LabKey Server, we have managed user passwords in the LabKey database. And so these rules really apply to that category of password. So it's not relevant for groups that are doing LDAP authentication against Active Directory or some other LDAP server, or if you're using single sign-on SSO like CAS or SAML systems. Those systems would then be responsible for validating whatever password, making sure it meets whatever rules are established for the institution. Don't worry, anytime that we store credentials, we are hashing and salting them in the LabKey database. So even if some evildoer gets their hands on, say, a database backup, they can't reconstitute the passwords. Every time I see about password breaches, I'm amazed at the number of groups that don't even take that basic security step. So that's foundational. That's been there from day one. And as a reminder, even if you're using LDAP and SSO as your primary way to authenticate, always have at least one administrator with a LabKey database managed password, so that if, for example, your LDAP server goes offline, or there's a configuration change that affects how LabKey is authenticating against it, you can get in and make those configuration changes. We've definitely had groups who have, there's been, let's say, maintenance on their SSO server or their LDAP server, and they've been glad to be able to log in directly to that LabKey managed password so they can re-enable that connection after correcting whatever change might have been needed. So for the LabKey managed passwords, the historical rules, I think Adam touched on this briefly, is that we've had two categories. One is weak, which is indeed weak, and really just intended for development servers so that lazy developers didn't have to type in too long of a password. And basically we said it has to be at least 6 characters and it can't be the same as your email address. Strong, which is the default for production servers, and we hope is what everyone's been using to date. You have to have at least 8 characters, and you have to have a mix of character classes. So that's uppercase letters, lowercase letters, numbers, symbols, that you'd have to have at least 3 out of those 4 represented by at least 1 character in that password. And it also has a strong prohibition against repeating more than 3 characters in a row from your user info. So that might be from your email address or from your user's display name. And I'll give an example of something along those lines in a second here to make that clear. So those were more or less in line with best practices in the early days of LabKey Server, but we've seen kind of the expectations change. The wide and ubiquitous use of password managers and automatic generated passwords and things like that. So we thought this was a great chance to kind of really up our game in terms of what we are offering in terms of validation of potential passwords on the server side, as well as just really aligning with overall industry best practice. So weak will that original setting, really intended just for development machines, will be removed completely early next year in the 23.11 release that's coming up. We're deprecating it. So sorry, developers. We can all make use of password managers and have real passwords used across the board. Because we're upping our game overall, we are renaming our old strong rules to good. You might even say they're a little meh, but good is our chosen nomenclature there. And then strong is really the new and improved approach, and it's quite a bit different in terms of its expectations compared to kind of the old approach of you must have at least 8 characters and that mix of symbols. And I'm sure you've all been annoyed by maybe the symbol that you were trying to use in a password isn't in the list of 4 symbols that a given service allows in a password. Just kind of all those overlapping rules are really annoying. So we've tried to be very accepting of anything that is a good password, but also filter out anything that's not. So instead of relying on those kind of raw character counts, what we've switched to is something that NIST, so National Institute of Standards and Technology, or something along those lines, has recommended, which is to grade passwords based on entropy, which is a measure of randomness, a little different from the physics use, but it's the same basic concept, where basically every character that you add to a password increases the entropy of that. And so you get credit for longer passwords. So the longer it is, the more kind of randomness it is likely to contain. And the wider the set of characters that you use in there, again, the more randomness you're likely packing in. If you're using only, say, lowercase letters, there's probably less randomness involved in each character itself compared to if you're doing a mix of character classes, upper, lower, symbols, numbers, etc. But the cool thing about this is we don't have to have strict rules anymore about you must have at least one of one symbol, but not the bad symbols. or the ones that we haven't chosen. Basically, you get credit for whatever you're using, whether it's a very long password, a great mix of different character classes. And the other thing that I really like about this approach is that it doesn't reject passwords that don't or that contain things that we don't like. Basically, you just don't get credit for that section in our scoring based on entropy. So things like repeated characters. So if you just say 111111111, basically that is treated more like a one character password in terms of scoring. Basically, we'll filter out anything that overlaps with your user info. So instead of prohibiting the use of something from your email address, for example, we just say, okay, that's fine if you want it in there, but you don't get credit towards the entropy count. And then we also filter out common sequences, like if you're just typing across, the row of a keyboard, left to right or right to left, you won't get credit for those either. So these rules are now part of 2311. They're available across the board, including the community edition. And let me kind of run through a couple examples here, because I think this is helpful to help people calibrate on what does 60 bits of entropy mean? Who knows? So I've got a handful of example passwords here, and they're scoring for the number of entropy bits that the algorithm, and we just adopted a very standard algorithm for scoring a password. And then some notes. So bad login, all lowercase, so we're not getting credit for that diversity of characters, and it's not very long, so that's well short of our 60-bit threshold. Here I've got repeated characters, repeated sequences in there, so basically it's scored exactly the same as bad login, because basically these are part of the password, they just don't count, don't give you credit for the entropy bits. So here I've introduced a little more variation. I've gone from all lowercase to one uppercase, so I got a little more credit, but I'm still way short of 60. Here I've got LabKey, which is part of at least this hypothetical user's email address, labkey.com, and so that gets filtered out and it gets scored the same way. I'd start adding a number. Okay, I'm getting closer. I add a bunch of numbers, but they're just right across the keyboard. And so basically I only get credit for that first one. That score's the same. I start adding symbols instead. Okay, the set of symbols is a little bigger than the set of numbers, so I get a little more credit for that than I did just adding the one. And now I start getting into the good range that crosses that 60-bit threshold, where it's either long enough or it's got a wider mix, and so you can see the score keep going up. Or kind of if you get to something like this, you're well above 60, and basically anything that a password generator is going to generate will both be accepted as an eligible password and meet our entropy threshold. So because it's a little more confusing to explain that entropy calculation to users, it's not the at least 8 characters, must have a mix of 3 out of 4 character classes. We're switching to show a real-time password strength indicator. You've probably seen these on at least a couple of websites when you set up passwords. It kind of goes the bar from left to right, saying not secure enough to good to very good or something along those lines. So we hope to get that into our release just next month in November 2311. And the way this will manifest, anytime you change these password rules, going from weak to strong or old strong to new strong, is the next time a user logs in, we'll check the password to see if it meets the rules for the current configuration of the server. And if it doesn't, they'll be prompted to change it as part of that login sequence. So it should be minimally disruptive to folks. But they, of course, need to have a password that meets the server's expectations. And then I'm not quite sure if it'll make it into 2311 or not. Might be the next major release. We want to make these more configurable for organizations that want to be more aggressive. So instead of going with our default of 60 entropy bits, you could dial that up. to be 70 or 80 or whatever your threshold is. And then also allow you to mix and match that with other checks like minimum number of characters or a variety of character types. That's not our recommended approach. We really think the entropy rules are strong enough on their own, but understand that sometimes there's institutional requirements, and we want to support those as well. I should say thanks to Adam and Stuart for really spearheading that upgrade. Two-factor authentication. This is work that Wendy and Binal and Sweta, among others, have been very actively engaged in, and kind of expanding our support. So quick reminder on authentication. Basically, there are three primary categories, let's say, of authentication. One is something you know, like a password or a PIN or something like that. Something that you have, it might be your phone, it might be like a YubiKey or some other physical device that that participates, or something that you are, biometrics, so like Face ID or fingerprint reader, retinal scan, those sorts of things. We have for a long time, I guess more than 5 years, maybe less than 10, supported a third-party service called Duo, which has an authenticator app and can also do SMS or callback authentication to either give you a code or just to say, yes, that's me logging in their app as part of that login sequence. And what we've added here in new release is support for a standard protocol called time-based one-time password, or TOTP, which you may not know by that acronym, but I'm sure you've seen it out in the wild. It's widely used. There are many third-party authenticator apps or libraries that you can use for kind of API-based use cases. So like Google Authenticator, Microsoft Authenticator, Authy, a lot of password managers might have this built in as well. Basic sequence is you log in normally. If this has become enabled, or if you're a brand new user to a server where this is required, you establish your password, and it says, great, time to set up your two-factor auth. You get this 2D barcode that you scan with your phone, and initialize the app. And basically all that is a convenient way to type in that horrific setup key down below, which is really the shared private that the private information, private key that the client and the server both have, and then they combine that with the time that they both have, and so hopefully they're very much in sync. In general, your cell phone updates based on the network, and so it's a lot more likely to be synchronized with the real time than your microwave. And every 30 seconds, they'll hash together the key that they've exchanged via this 2D barcode and the current timestamp, and then user types in a 6-digit code, server authenticates that, and the user's logged in and ready to go. So this is part of 23.9. Like most of our authentication integrations, this is part of Starter Edition and up. So professional and enterprise get this as well. So we're excited to have that and expect to be configuring more of our own internal servers to be using this. So we've got a variety of changes here for how we handle certain types of API calls. So a little bit of a grab bag of kind of release note type things. But as of recent work, we've kind of added more consistency between how we do audit logging and other types of logging for client API calls, especially around API keys. So expect to see some updates there if you're a frequent viewer of the user event API, or sorry, audit log table. And really want to encourage people, if you're not already using API keys in your client API calls, please start doing that. It's much stronger than username and password. We can individually revoke API keys and manage them separately. You can have separate API keys for each of the different clients that you expect to kind of better correlate activity and that credential. And if you are enabling two-factor authentication, whether that's via TOTP or via Duo, API keys are the only way that you'll be able to do that for these client API calls. And then kind of a slightly different note, but still within the API realm, we've made changes over the last year, including more recently towards the 23.11 release, basically to help reduce the false positives that different security tools have flagged on LabKey Server API calls and just general client server interactions. So these typically come from one of two categories of tools. So one is a web application firewall, or WAF. This is something that actively intercepts every single call HTTP request from a client to the LabKey server and rejects some of them based on clear abuse or malicious content. Kind of very common things to filter out are API calls or HTTP calls that look like they're trying to exploit WordPress or other kind of third-party tools and servers where people just have bots. And if you've looked at HTTP access logs, you've seen all sorts of malicious activity that's out there on the public internet. And so we want to encourage people to be able to use web application firewalls, but not have that flag legitimate traffic. And one of the things that we've seen in our own deployments is that the WAF will sometimes reject API calls that include LabKey SQL, which is a legitimate use case in LabKey Server, because LabKey SQL is designed to be read-only, to be safe against SQL injection, and go through all of our own security layers and authentication and all those things. So it's completely safe to run, but to the WAF, it looks like someone's trying to do a SQL injection attack, and it may block it. So we've seen that on some of our cloud managed servers. We've seen that on reports from people who have a WAF in front of their on-premise deployment. And so we've changed the way that parameter gets passed. So if you've got client API libraries, especially the ones that are not the JavaScript API that just gets automatically bundled with the server, you'll want to go ahead and upgrade to the latest LabKey client library version for your language after you've upgraded to 23.11, because the server otherwise won't be able to understand the way that SQL is being passed. And then the other thing kind of along those lines that we've worked on is we have received many results from security scans that folks have used, a variety of commercial tools or open source tools against their servers. Some of them have many false positives that were based on the tool not liking the fact that LabKey had reflected back a potentially malicious value from the request. So that would be something like passing as a schema name parameter, something that looks like it could be cross-site scripted content or something along those lines. LabKey was always passing that back in a way that was properly encoded, so it would not be executed as script, but these security scanners continued to flag it as needing review. And basically we said, great, we've got an opportunity here to reduce the noise in all these scans, make everyone's life easier, not having to justify why this is properly encoded. So just in a lot of cases, reduce the number of things that we reflect back, makes the error message slightly less useful, less helpful for a user who encounters that. but really makes kind of reviewing the results of these security scans so much smoother. Content security policy. So this is something that Matt has really championed within LabKey, and Trey has been doing a lot of testing to kind of help roll out. Also thanks to John on our systems engineering team for getting this deployed on cloud instances across the board. So content security policy is a web standard to help protect against many common types of web attacks. So cross-site scripting is really one of the kind of banes of the web's existence. The web was not really designed to prevent that originally, and so there are many mitigations that we all need to put in place to keep everything secure against it. And then there's a lot of different kind of either variants or kind of slightly less popular but still pernicious types of attacks that content security policy can help mitigate. So basically, it's a way for the server to tell the browser what else it's allowed to connect to download resources or ways to execute script. And really, the main thing that we're focused on is that JavaScript angle, the cross-site scripting, trying to make sure that we've as Stuart on our systems engineering team likes to say, got a belt and suspenders approach, kind of redundant ways to keep our pants from falling down, because this cross-site scripting is really, just a very bad thing if it were to sneak in by any angle. So this is complementary with other approaches. We don't ever want to, rely solely on one approach to keep us safe. We want to have full protection through multiple channels. So it won't prevent us from doing things like properly encoding HTML content, being very strict about who is allowed to add any JavaScript code in a wiki or other resource. But content security policy can really help us stay strong here. So it replaces a bunch of deprecated HTTP headers, some of which were never really standards and never really worked either. The XSS protection header, I think, had really marginal value to begin with. But the new content security policy header is something that the server writes back as a header in the HTTP response. And to very briefly kind of show what this looks like, the simplest one you could possibly do is say the default source, so any type of source, whether that's images or audio or script or anything else, is self. Basically, don't ever get content from some other server as part of rendering a page. So even if the server were to have an image with a source tag that goes to some third-party server, the browser would reject it and just probably show a broken image instead of downloading that image. This is a way to prevent people from sneaking in malicious content to say, no, we know what servers are supposed to have content related to this LabKey deployment. Let's instruct the browser only to go to those. So if through some exploit someone has managed to point at external content, the browser is just going to say, no, I know better based on that content security policy. So a more complicated one would be to say, oh, I can get images from anywhere. Those are pretty safe. I can only get media, so audio or video or that sort of thing, from, say, this server, these two servers, example.org or example.net. Scripts I can also get from this user scripts example. And so content security policy for many kind of major websites can get very complicated because they've got content delivery networks, CDNs, and all sorts of other things. For a LabKey deployment, they tend to be much simpler because we're not typically serving things outside of that LabKey instance itself. This is configured in Tomcat. It's separate from the LabKey web application itself. So if you're running on-premise, this would be an extra step to set up. And we are basically getting stricter about the CSP that we intend to deploy, and getting rid of inline JavaScript across all of the HTML that we generate. And one particularly tricky spot here to do the right thing is in kind of user-generated content, so wikis that might have JavaScript. So if a user has developer permission where they're allowed to put JavaScript in there, we'll actually kind of rewrite that JavaScript so that it's in compliance with our stronger CSP recommendations going forward. We automatically deploy this as part of a LabKey Cloud instance. And if you have a LabKey Cloud instance and you need to leverage a third-party hosted JavaScript, maybe there's you always want to be getting the current version of some third-party library pulled into that page. Let us know. We're happy to adjust the CSP for your install to accommodate. But know that by default, you're getting more secure with each release along these lines. And then the last major category is just want to touch briefly on checks that we've added to our process over the years. Some of these are new, some of these are longstanding, to make sure that all of the library code, all the third-party open source libraries that we depend on are secure. So CVE, common vulnerabilities and exposures. This is a common NIST supported effort and kind of industry-wide effort to track security issues. There's a real range of severity. They all get scored. And there's great debate sometimes on whether something's actually a CVE or a feature, but that's what we're checking against. And then we've got nightly test suites that run checks, kind of reconciling our list of third-party dependencies against the CVE listing and making sure there's no overlap. And then if there is something that a new CVE that comes in, we either upgrade or we verify that we're not vulnerable. I mean, we'll still upgrade as soon as the patched version of the library is available, regardless. But essentially, we're keeping that list at a 0 CVE match, so that we've got a clean bill of health going forward. And then this is complementary with things that we do for LabKey Cloud deployment. Some of these are specific to compliant cloud offerings for people who are using compliant cloud for PHI or other kind of extra restriction types of data. And so again, we've got kind of multiple checks, multiple tools running these comparisons so that we can be sure we're fully covered. And then last, I thought it'd be good to highlight our hotfix policy. So if there's a problem of any kind in LabKey Server, Sample Manager, Biologics, we will use this decision-making criteria and these remediation steps to make sure we get every install protected. And so we categorize it based on kind of this low, medium, high rating. And you can see there's more information on our website for how we score these. Our scoring may not be the same as the CVE's scored because our usage is a little bit different. But we make some common assumptions there, and then we'll get that patched, possibly on an emergency basis, possibly kind of in the next major release, and communicate to our customers and the overall community if there's any issues. So with that, I think I'm going to right at time, but happy to take questions for a minute or two before handing it off.
Yeah, we've got a couple of questions here, Josh. First, will TOTP be used for non-session-based API keys as well?
So, right, we've got two styles of API key. One is what we call a session API key. So that is tied to kind of that individual login. So you have to go authenticate to the server, get the session key, and then hand that off to your library that's making the call. Then we've got, think of them as the kind of persistent API keys. So both of those will not be blocked or subject to the TOTP or Duo two-factor authentication. Basically, either type of API key, whether it's session-based or not, won't be blocked by.
And second question here, are we going to be including password expiration? Is it going to be configurable? Is there going to be default values for that?
So that is, we haven't explicitly made any changes there for kind of related to the password rules. We do have capabilities that I didn't highlight around this in terms of kind of locking out password after a certain number of failed login attempts and things like that. So that hasn't changed. And then but happy to always get input from folks on what aligns with your institutional practices. What do you want to see here? And of course, anything that is delegating to LDAP or single sign-on for that authentication, that's ultimately the system that manages the expiration and so forth for those credentials.
Great. And a final question here might be a bit long, but you tell me, Josh. For persistent API keys, can you provide an endpoint to fetch a session API key that would require TOTP code?
I'd say let's talk about that scenario. I think we've definitely been thinking about how to have these interact. We've thought about, and I think we have support. Can follow up for sure to confirm to pass TOTP codes as part of a client API call. So we've got kind of a combination of things that we might be able to leverage what we've got, or maybe there's some small adjustments to provide a new endpoint to support that particular one. So happy to follow up offline.